So, my name's Dylan. My name's Dylan, and I'm going to give a talk on Elm. I haven't actually written a whole lot of Elm. I've sort of like used it on and off on side projects for a few months, but I did use it professionally for about 8 weeks at work. So I think that gives me more professional experience with Elm than anyone else in this room probably. So I think that's enough to entitle me to talk about it. So in case you don't know, actually, first off, who's heard of Elm before? Raise your hand, please. Alright, who's used Elm before? That's pretty good. I just want one who uses TypeScript, or has used TypeScript. Alright, good. I got a couple examples in TypeScript compared to Elm. So anyway, Elm is a programming language from 2012 that compiles to JavaScript. It was designed to make feature-rich applications, think YouTube, AV, and Facebook, so not like blogs or anything, but like actual apps with things going on. The biggest promise of Elm is the zero runtime errors, the friendly developer experience, and the JavaScript interop. So I think the main reason a lot of people like to use Elm is because of the zero runtime errors, because if you use a lot of JavaScript, there'll be lots of times where you cannot read, null undefined or
there's not a function.
No, yeah, undefined is not a function, like it happens all the time, whereas Elm, once it compiles, it generally works, so you don't have to waste time on that. So it's a pure functional language with advanced types, pattern matching, and composition, and I'll go into that with my examples. So some reason why you would want to use Elm is it allows you to make changes with a fast feedback loop. It's a compiled language, it's not interpreted, so if it compiles and your types work, it generally works. You don't have to like run it and then click around your app a bunch, see if it crashes, try and make a code change, click around your app, it'll just compile and then generally works. So you waste less time. Even large code bases will compile in less than 2 seconds. Like I've heard of apps with like 400,000 lines and it'll type check in less than 2 seconds. So in less than 2 seconds, you know this giant app works. Like it's pretty amazing. It has a tiny compiled JS size, so there's a repo where they do a real-world app, which is a clone of Medium, and the React version is 77 kilobytes, the Elm version is 29 kilobytes. The reason why it has a small bundle is because it's a pure functional language. It can do function level dead code elimination because there's no so like in JavaScript when you import, the bundlers have trouble deciding what to import in what order and things like that, which can blow your bundle size, whereas the latest version of Elm just like go through and eliminate code at a function level, so you get the smallest possible bundle. If you ever had like a case where you needed extreme perf, that might be useful. Another good thing is it has baked-in state management. It's pretty much like inspired Redux, so it's similar to that. It's type system and compiler, so you don't need to rely on like several tools working together well. You only have to get the compiler and you're pretty much good to go. So this actually allows you to learn the entire API in a couple of weeks. When I was doing this at work, we had a little bit of trouble. Like we made an app that had multiple pages, dealt with authentication and fetching data from a HTTP request. It took a couple of weeks for us to someone who'd never written functional code before, it took them a couple of weeks to get used to it, but then after that it was fine. So you can pretty much, in a couple of weeks, learn the entire API, and at that point there's no more else to learn. Like you pretty much learn Elm, and you can make any app. The type system enforces semver on Elm packages. That's a good nice to have. Like you don't have to worry about your npm packages getting a patch version and breaking everything. Elm will actually check for Elm packages the type signatures, and if any change, it'll do automatic semver, so you always get more guarantees that your app works. It's also good for gaining experience with a functional type system, which is more advanced than C# and TypeScript. It's not as advanced as Haskell, but if you want to get some experience with functional type system, it's certainly very useful. There's a lot of reasons why you wouldn't use Elm as well, because it's a relatively new language and it's fairly niche. The main drawback is it has a small ecosystem. There aren't many pre-made components, which makes getting started quite slow. I know with React you can just be just install drop downs and everything like that, like whatever you'd ever need really quickly and get started, whereas Elm, it has a lot of core libraries, but not much use cases, because especially with date pickers, there's dozens that you could potentially need to use, whereas Elm only has 1 or 2. So you'd have to spend a lot of time modifying that for whatever your business requirements are. It has a small community with not much on Stack Overflow. This is a bit of a drawback because you don't get SEO. Like if you have an issue and you Google it, it's probably not going to come up. You're going to have to go to Slack and then ask someone. The Slack's really good. People get back to you within like 15 minutes or less usually, so it's not that big a deal. But of course, you just get the issue where people just ask the same questions over and over and over again because there's no like resource like Stack Overflow where people can just search for it and get the answer without having to ask. There aren't many jobs that use Elm. Like it's sort of had like fairly stagnant growth. Like there are companies that used it, experimented with it, and then either like continued using it or not used it. The company I worked with, we used Elm for like a small app, and then when it came to building a much larger app, we decided not to use Elm because we're hiring a lot of developers and they're more familiar with C# and TypeScript, so it would have just been like, even though it's only, you can learn it in a couple of weeks, it would like compound, and we just didn't have time. The different paradigm can be difficult to get to minimal productive knowledge. Like obviously, if you already know React and web apps, you can just pump something out in like 10 seconds, whereas Elm, you sort of have to know most of that API if you want to build like a full app. So it takes a little while to get to that level, but the API is really small, so once you know it, you pretty much said. So I imagine that with this graph, which isn't accurate at all, but I imagine it probably plays out like this, just from my experience, where the more code you write, the more chance of errors when you make changes in the code. I know JavaScript, like, it very quickly gets to the point where even making small changes, you have to have a massive regression test suite to make sure you didn't break anything, even if you just change the smallest bit of code, just because of the way it works and you don't know at compile time what's happened. TypeScript's good. Like TypeScript gives you more scalability, a lot more than JavaScript, which is I'm guessing like it's like really popular now because people are building bigger apps. They need a bit more safety, but I think Elm holds probably the best. Like, well, that chance of error should be lower. It's more like a productivity thing, like productivity versus errors. I like mislabeled the axes a bit there, but Elm's sort of a bit slower to get going. But as your app gets bigger, you start getting the returns. So it really depends on the scale of application you're building, which I guess this probably hurts adoption because people probably want to start with a small app. They make a small app and they're like, oh, I don't get any errors in the TypeScript version either, and it was easy. But it starts to pay off the bigger your app gets. So like having that compile time check across like a $400,000, 4,000 line code base saves you a lot of time compared to like TypeScript or JavaScript having to run a bunch of tests. So there are a few companies using Elm. In Australia, there's a company called Pacific Health Dynamics and Culture Amp. They have blogs on it, and they also post podcasts on Elm, so it's pretty nice that we have companies in Australia. AWS hired for Elm for internal admin dashboards. NeuroLink is educational software, and IBM built a user-facing app as well. So I think with Elm, these use cases are quite good. Like the internal admin dashboard, it's like you don't want it to ever like crash or anything, so like Elm gives you a bit more guarantee there. And it's like an internal tool, so it's not really like, you don't need to have like really flashy features or anything, so it sort of plays well to Elm's strengths. NeuroLink's similar, like it's educational software, it's B2B, they might not have like a strong like pipeline into schools, so like if there's a bug, they probably cost them more to fix it, so I think Elm works well for them because they can just push it and then they know it's going to work, like, because it's functional, because there's only runtime error, sorry. And then IBM experimented with it, and they actually, there's a write-up they did on Discourse, so you can read that if you want. They actually, yeah, they really enjoyed it. It was like a GUI for managing some ops on their cloud platform, like where the logs go and stuff, and it seems to have worked quite well for them. All these slides are posted in the Slack if you want to follow along, sorry. But yeah, you can just go down to the Slack and get on those links. So like, just at this point, does anyone have any thoughts or anything on Elm from what I've said?
I think I had on one of the Elmcasts that it was Microsoft were using it in the help system for Word or something.
Yeah.
Yeah,
there's lots of like small projects at big companies using Elm. I didn't list them all here, but it seems to be like, yeah, there's use cases where it seems to fit quite well with these big companies with like tooling and things. So I think that's a good place. If you were to adopt Elm at work, maybe an internal tool or something would be a good place to start adopting it, because you don't really care about it being flashy, but you want it to like always work because it's like important. So that might be a good place.
Does Microsoft's got run JavaScript?
Yeah, probably.
Right. The disadvantages of using Elm, one of the ones that stop me from using it is that it's not a general purpose programming language, so you can't use it on the server. So like if you wanted to have a shared library code between server and client, that's quite nice in TypeScript, you can do that, you can have like a shared API, but with Elm you can't do that. Do you know why? I think when I read about it, they just wanted it to be like focused, like laser focused, that's what we do. But is there any other specific reason why they don't make it general purpose?
Yeah, they're pretty much trying to set out to solve the front end space. They're not really worried about the back end. They said that if they were to add back end support, it would take potentially years, and then like they're trying to solve just the front end because it's only really like
to do a release anyway.
yeah, exactly. Like there's only like one or two people actually pushing the compiler forward, so
Why?
they just don't have the resources.
I don't understand that. Why don't you just, because it's targeting JavaScript, compiles JavaScript anyway, why couldn't it just target Node?
You can. There's an experimental like GitHub repos where it targets Node, but to actually support that officially as part of the compiler, they said would be like, because what they're trying to do with Elm is actually like solve the state management and like all that kind of stuff. They're not just trying to like make something that compiles to JavaScript and then works on anything. Like if they went into Node, they probably have to release, like, because it includes everything. It's not just like a general purpose language. It like does front end, so they have to make like an Elm back end, which is like has all these built-in libraries that probably copies Elixir or something. Like if they found out that was the best way to do back end kind of work.
And then effect managers for everything.
Yeah, so they have to like find out. They have to like come up with new effects managers and all these new concepts because they're trying to make it a battery included language. So like you just need Elm and you can make front end apps. Whereas if they had back end, they'd have to make their own, make a bunch of effects managers and maybe like hashes for storing secrets and stuff like that. So I think that's the main reason.
So the Elm architecture isn't just like a library, it's actually baked into the language itself.
Yeah,
In the runtime.
it's part of the runtime.
Okay, so, but they don't have like specific keywords and stuff, that syntax in the language that prevents them from, do you know, I don't understand why it isn't just a library, like the architecture, just like, you know, Redux or React is on top of JavaScript.
Okay, it's not a library written in Elm, it's a library, just part of the, I don't know if the compiler speaks up JavaScript at that point.
Probably the closest thing that you to what you're after would be reason.ml and reason React.
Yeah, I know. Yeah, maybe all this, but I was wondering why Elm specifically didn't, if it's so good, you know, why can't it just be?
Because I think because they want to get that API surface area as small as possible and make it.
It's not true,
approachable.
That's the thing, you were mentioning the effects, and that's probably important.
Yeah, like
In the Elm architecture,
the idea is that you get Elm and you're done. It's not you get Elm and then you choose from 8 different architectural libraries. Because if there was, you know, like there's batteries included, so they're like if they want to do the Elm approach to backend, they'd have to make a complete system that does every backend thing. Whereas Elm, because Elm at the moment does every front end thing. Like it's not plug and play. It's just you get Elm and this is how you make Elm apps. So when you go on the internet and you look at other people's code, you're like, doesn't matter what Elm project you look at, they're all going to be the same. Like they're all using the same patterns. Like there's one way to do it. People can learn it super quick. It's super like useful because no runtime errors. So I think that's the idea. Like they don't want to make it too generic because then you compromise. Like you have to make it, it's hard to learn because then you have to learn Elm plus Elm React View or Elm like some other view library. Like it just gets too complicated.
Yeah, I appreciate that, but I think it's one thing that's going to hold it back, isn't it?
I think they've said they will look at it in like the future, the future TM. Like one day we'll get it. Like just I don't know. It's hardly releasing as it is. So like, so yeah, here's just some info on how to get started. I'm going to repeat this at the end anyway, so it doesn't really matter. But there's an official guide which has a lot of good examples. So that's probably the best way to get started. You just go through that, and you can maybe download the compiler and have a bit of a play with it. The official Slack channel is pretty much necessary because you can't Google for a lot of things because it doesn't have much activity on Stack Overflow.
What is the Slack channel called?
If you just Google it on Slack, it'll be the first thing. Sorry, I'll put a link in. try it. Oh, there's this project called Eliat, which is like, it's an online REPL for Elm. So this is where all my examples of this talk are going to be. So this is really cool. So you can write your HTML with JavaScript and then Elm code, and then you got it on the right. So that's a pretty useful way to get started. If you were to actually like build a proper app and you wanted the most opinionated thing possible, Elm's already quite opinionated. You can't really mess with it too much. But if you wanted some help on like how to structure your app, like folder structure or something, if you have like an Angular background, there's a GitHub repo called Spades that comes with built-in SSR. Elm doesn't, it doesn't have like an official strategy for SSR, but this just like rams a node process in front, so it just uses node to run the JavaScript, and then you can get SSR on your Elm apps. So it's pretty good, and it has code down for everything, so that's useful. So yeah, on to, right, so I'm going to be talking about what Elm actually is and how it works. Probably the best example is like, how does Elm actually get the no runtime errors? And that's because the type system uses a functional type system, kind of like Haskell's. A good example for that, to like wrap your head around it, is like this maybe type, where it's maybe A, and A means anything, like can be a record or can be an int or a list or whatever. And it has a union type of just the value or nothing. So an example where it's used is in the list head. If you like have a list of actual values, you'll get the value, whereas if you have a list of nothing, you'll get nothing. So now you don't have issues where it's like in JavaScript where you like try to access an array, the array doesn't exist and it just explodes. Like that pretty much can't happen in Elm because you always get one of these types. And the way you have to deal with it is you have to pattern match out of the types. So you have to pattern match across every possible result. So here I have a little example. Some of the best code I haven't written Elm for a while, but so I have a button, and pretty much it just gets an item from this list. And here in the code, I'm pattern matching on the list method for getting the item from the array. So if I get it now, it gives me 2, which is the first item. But if I change it to an empty array, file that, it'll give me 99. Because that's my nothing case, I've handled it here. If I just delete this nothing case, I'm like, whatever, I'm always going to have a list there, lol. There will be a compile error. It'll say you haven't handled all the cases. So I haven't handled the case where there happens to be a list that doesn't have values in it. So it just won't compile. So I can't ever get that error where I'm accessing part of a list that doesn't have value in it. And yeah, that's pretty much the main way it gives you that runtime guarantee. It forces you to pattern match across all the different possible outcomes for all your code, and you can't ever have like a edge case that isn't being covered by something. And here's just a quick example in TypeScript. If you use TypeScript, I've just made like a maybe type here where I use this type value, and it's part of these enums. And then you pretty much just, like I made a sakehead method, and you just handle the 2 cases. This sometimes doesn't work for some reason. I don't think this REPL is very good. But you can just copy this pattern in TypeScript. I use this all the time in all my work pretty much. Like, it's really useful. Like, if you ever had something where it's like, it may be there, it may not be there, you can always like make a method like this. I mean, you can put more checks in. Like, I'd probably put in like, make sure it actually is an array, but the TypeScript should handle that up here, so it's probably fine. But I know that every time I use this sakehead method on an array, like, it'll always force me to, like, I can always write this switch statement, and then I can always handle every possible case. So I'd end up with cases where there's no value there and it just explodes. Because TypeScript can still give you that. You can still get empty lists, because an empty list is still a list. Yeah, just get issues. So that's an advantage of them. This is pretty much the meat of the talk. So I just pause. Does anyone have thoughts on that, on the type system?
How have you found, as a TypeScript background developer, how have you found using this nominal type system as opposed to structural type system on your productivity? Because, like you say user ID equals string and message ID equals string, but you can't then compare those 2 together. But in TypeScript you could because you've structurally compared them.
Elm is structural
Is it?
as a record type.
Okay, alright.
Yeah.
So have you found it that it hasn't hampered your productivity at all, like having it like a stricter type system?
Yeah, that's the trade-off you make. Like on my graph with the lines, which wasn't, I should label my axes better. You do pay a bit, but you save also. Like TypeScript's good, but if you go to any TypeScript library on the internet, like any npm or typed, definitely typed, there's just any's everywhere. Like it works 95% of the time, whereas Elm works almost 100% of the time. Like I've heard people have apps with like 80, like Neuridic has an app, it's like 400k lines, they've had 0 errors in 5 years or something on their Elm. Like, you can't get runtime errors. Whereas TypeScript is, you almost can't get runtime errors. But you can always just write garbage TypeScript. There's no shortcuts in Elm. You can't like, well, you can give like a star pattern on your pattern matching and just match all the edge cases into one thing, but you have to handle everything. So there's no shortcuts. You have to write it quite long. It's more verbose, obviously, because you're handling every case, and just the language in general, like, I think just takes more lines, like with the types, they're always on new lines, like everything is put across new lines by default from the built-in formatter. But the trade-off is that when it works, it almost always like works. Like there's no edge cases you're missing or anything like that. Whereas TypeScript, you have to be very disciplined and like use like my example where you're like matching on, like switching on stuff to avoid having edge cases you don't cover. Like it's just, and also I think another thing is with TypeScript is if you're going to that really strongly typed, like never having edge cases scenario, you're sort of like that functional style. You're trying to fit like a square into a circle. At times, like you're writing all this code. Like if you look at the like my TypeScript example is like 1 trillion lines just to give me a maybe, whereas Elm's like literally this.
Yeah,
Like
I'm making the same argument on the IOTS GitHub issues at the moment that like they're trying to like fit a square peg in a round hole, you know, trying to make normal